Today, let us study our topic on register and mainly shift registers. Register basically is a storage space and mainly stores information in binary format, as we all know. And shift register basically is required for transferring or shifting the data to the different location inside the system and mainly to the central processing unit, which does data processing and gives us results which are again shifted to the memory unit as such. So shifting is required for processing to be done by the central processing unit mainly. And there are mainly four types of shift registers mainly, that is serial in serial out shift register, serial in parallel out shift register, parallel in serial out shift register, and parallel in parallel out shift register. Here I have shown just an example of a register in which we have data as 1010100001. This is just nothing. Okay, that's why I have put a cross over here. This is a cell, this is another cell, and this is another cell. So these are 8 different cells. Each cell is made up of a flip-flop, and flip-flop has the property that it stores binary information in the form of 1 or 0. So the registers are mainly built up of or made up of flip-flops mainly. So now coming back to the main topic, that is serial in serial out shift register. Here I have shown a diagram that is a 4-bit shift register, and it's a 4-bit shift register as there are 4 flip-flops being shown: flip-flop A, flip-flop B, flip-flop C, flip-flop D. And we can see that these are all cascaded. Cascaded means the output of this flip-flop is connected to as an input to this flip-flop. The output of this flip-flop is connected to this, and likewise. So this is known as cascading. And also there is a common clock which is connected to all these flip-flops. As you can see, it's going to this, it's going to this, it's going to this flip-flop. And since there is a common clock being connected to all the flip-flops, the flip-flops are known to be synchronized. And also, since this is a flip-flop, the flip-flop has a property that it stores a binary information, that is either a 1 or a 0. And particularly here we have used D flip-flop. D flip-flop again has a characteristic that there is only one input being supplied to D flip-flop, and there are outputs as Q and Q bar, that is one is the normal output and there is a complement output. And it has a property that whatever input is given, the output stores the same. If the input applied is 1, the output will be 1. If input applied is 0, it will store 0 as the output. So now, to understand the working of this particular register, let us take an example of raw data as 1010. In this particular example, we know that this is the least significant bit and this is the most significant bit. So now we'll see how the serial inputting is done in this particular register. So what we'll do is we'll apply 0, then we'll apply 1, then we'll apply 0. Again in the last we will apply 1 to the serial data input. So now to understand the working of this, let us take, these are the relevant diagrams to understand the working. This is our raw data. Okay, what we are doing is the least significant bit is applied as the data input, and on applying the clock pulse, what will happen, the output over here will store 0 and rest of the flip-flops are empty still. So after first clock pulse, in the very step 1, the output will be Q3 is equal to 0 and Q2, Q1, Q0 as X. Then followed by the next bit is 1. So in the second step, what we are doing is we are applying 1 on the data input, and on applying the clock again, so what will happen? This particular flip-flop will store 1 and the 0 which was stored over here, that will be shifted to the next flip-flop. So Q2 is 0 now, and Q1 and Q0 will be nothing. Then in the third step, on applying the third clock pulse followed by the next data bit, that is 0, we apply over here. On applying the clock pulse, now Q3 will be 0, Q2 will be 1 and Q1 will be 0, and finally Q0 will be nothing now. In the step 4, on applying the fourth clock pulse now and on applying the last bit, that is 1, so what will be? Q3 will store 1, Q2 will be 0, Q1 will be 1 and Q0 will be 0. So this is what our raw data is, 1 0 1 0. So this is how inputting, and that too in serial manner, has taken place in this particular register. Now further, to have a look at the serial outputting, how outputting takes place in this particular register, it's not a very difficult task. Just what you have to do is, in step 5 we have to apply the next clock pulse, that is on clock pulse 5 now, and then what will happen, you can see over here after step 4. Now when we apply the fifth clock pulse, since here now there will be no data as such, here there will be nothing, so when we apply the fifth clock pulse, what will happen, this 1 will be shifted to this flip-flop, this 0 will be shifted to this flip-flop, and this 1 will be shifted to this flip-flop. So what will be the scenario? It will be like this. Here there will be nothing now, so it will become like Q2 is equal to 1, Q1 is equal to 0, Q0 is equal to 1. Okay, then on the sixth clock pulse, it will be like Q3 will be nothing, Q2 will be nothing, Q1 will be 1 now, and Q0 will be 0. And finally, on applying the seventh clock pulse, it will be Q3 is equal to nothing, Q2 is equal to nothing, Q1 is equal to nothing, and Q0 is equal to 1. So this is how the inputting as well as outputting takes place in a serial input, serial output shift register. So this is how the working of SISO register takes place. Friends, now to understand the working of serial in parallel shift register, it's very easy, as the four steps are same like in serial in serial output shift register, as serial inputting will be done in the same manner as it was being done in the serial in serial out shift register. The only difference lies in the outputting. As you can see here, in serial in parallel out shift register, we are having respective output lines being connected to each flip-flop. That is, this particular flip-flop has an output line, as you can see, and this particular flip-flop, that is flip-flop B, has an output line Q2. This particular flip-flop C, here I forgot to write, flip-flop C has an output line Q1, and flip-flop D, and these are all D flip-flops. This is a D flip-flop as output line, that is Q0. So once, if we take the same data, that is 1 0 1 0, since it is serial in parallel out, the serial inputting will take place in the same manner. So once the output, that is in the form of serial manner, is stored like that, 1 0 1 0, as soon as the data is entered in this 4-bit shift register, all the data or bits are simultaneously available on the respective output lines also. That is, once the data has been entered in this particular register, the bits are available on the respective output lines also. So this is how both the serial in serial out and the serial in parallel out shift register working takes place. Thank you friends.